guys. So I tried to record myself completing this worksheet for you, but clearly I can't have my camera minimized and actually record my screen, which my document camera was doing. So I'm gonna just go over this. I'm holding this with my phone, so I just wanna make sure you guys know how to do this. This came with the Amoeba Sisters video about protein synthesis. And what we're looking at here on my computer, this is the messenger RNA codon chart, and you need to be able to read that. And then also over here, you need to know what we're looking at. I didn't ask you to do this on your assignment, and I'm gonna post this so you guys can check your answers, but I'm gonna go over it all right now. Anyway, when we're looking at this part here that was shaped like a T is your tRNA molecule. On one end is amino acid, and then down here is a 3-letter sequence called an anticodon. The anticodon matches up with a complementary sequence of 3 bases in messenger RNA. So down here is your messenger RNA, and the 3-letter sequence here is called a codon. And this is just a copy or a complement from the original DNA. So I wanted to make sure you guys could do that, even though I didn't ask you to do that on your assignment. You're supposed to answer the questions 2 through 21. So I'm going to tell you how I went through and did this. On this question number 2, when reading a codon chart, unless otherwise specified, you use bases from what? You're going to use the bases from messenger RNA. So you're not using the anticodon here. You're using the messenger RNA. That's what these codon charts are based on. So always use the messenger RNA. The codon chart demonstrates that more than one codon can potentially code for the same amino acid. That is true, and how you know that is, for example, valine. Valine over here, there's 4 different codes for valine. You've got GUU, GUC, GUA, GUG. They're all coding for the same thing. And the information in this rectangular codon chart can be represented in a different way. Yes, it can be represented as circles. There's all different types of codon charts for messenger RNA. How many different codon combinations are shown? The answer is 64. How you know that is because there's 64 lines. There's 4 in each square, and there's 16 squares, and 4 times 16 is 64. That means there's 64 combinations of U, C, A, and G in 3-letter sequences. And then how many different types of amino acids are shown? There's 20. And how I'd know that is I can count them. Phenylalanine is 1, leucine is 2, isoleucine is 3, methionine is 4, valine is 5, serine is 6, 7, 8, 9, 10, 11, 12, 13, and I'll go to 20, okay? And some of them were copied, so you can't count serine twice when you get to it, or arginine twice when you get to it. So there's 20 amino acids, okay? Then we're gonna come down here. You should be able to do this for your test. If they gave you in the video a messenger RNA codon of AUG, what would be the tRNA anticodon and what's the amino acid? So you look at the AUG and you see the complementary bases. In RNA, A goes with U, U with A, G with C, and then you use the messenger AUG, look it up on the chart, and it should give you, uh-oh, I lost connection, reload. It should give you methionine. So if we slide up and look at it, okay, methionine, it should be A, U, U is here. So we go A, U, and then G, and where they all meet is methionine. Okay, so that is how you look it up. I don't know what my problem is with my connection today, because I have not had any connection issues, but clearly I'm having one today. Okay, let's go down. I'm going to increase the size of this so you can see it better. Hopefully you'll see it better. Okay, so I'm not going to keep scrolling up to the chart, but I want to make sure you can read it. Okay, so if I have 3 bases, let's say it's U, 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 the U is above here. Okay, U, U, and then the line U, where they all 3 intersect, is phenylalanine. And a lot of times we'll just abbreviate it as the first 3 letters. So if I had CUU, it would be C, U, U, where they all come together, and I would abbreviate that as leucine. That's how you can tell. And if I tell you, okay, tyrosine, what is the code for tyrosine? You can look left, U, A, U, or it could be U, A, C. So you're just looking at all three bases, and they're in that order, first, second, and third. You can see that. So when you come down here, number 11, the video gave an example of identifying codons for an amino acid. Which 6 mRNA codons code for leucine? I just looked up leucine, and I saw the 6, and I looked up the 6 codons that it is, okay? And then I wrote them here, and I'm going to share this with you. So the answers are UUA, UUG, CUU, CUC, CUA, and CUG from looking at the chart. And the next question, number 12, what would be the 6 tRNA anticodons for the above mRNA codons? All you have to do is figure out the complementary bases, okay? So wherever there's a U, A bonds with it, UA, AU. So that's the complementary strand. AAU is the tRNA. Here, U goes with A, U goes with A, G goes with C. C goes with G, U goes with A, U goes with A. And you just keep going along, okay? In the next one, number 13, what would be the DNA base triplet on the DNA template with the messenger RNA strand above, okay? So if here's the messenger, what would have been the original DNA? U goes with A, U goes with A goes with T in DNA. So you don't write a U. We would say A goes with U if it's talking about RNA, but A goes with T in DNA. Okay, then we look here. We're looking at the messenger to get the DNA. U goes with A, U goes with A, G goes with C. C goes with G, U goes with A, U goes with A. C goes with G, U goes with A, C goes with G. Okay, so we got GAT and GAC. Okay, that's how you do that. Now, notice that these are almost the same except for T replaces U. Here they're the same. Here they're the same. Same. Here T replaces U. So your tRNA and DNA should match, and that makes sense because if you start with DNA and then you get the complement of messenger and then get the complement again, aren't you going back to the original? Yes, except for you're just swapping out the bases T and U. Okay, on 14, changing one base letter on mRNA will always change the amino acid it codes for. Lost my connection again. Will it always change the amino acid that it's coding for? No, it won't. And the reason for that is because you can have more than one codon. Okay, let's go back here. Okay, and let me increase the size again. Okay, because more than one codon can code for an amino acid, like valine, for example. Okay, there's more than one codon. So if we change one base letter, as long as it still fits into one of those, it will still give you the same amino acid. So not every error is the big problem. Okay, let's go down here. 16, the mRNA codon UGG is the only code that codes for the amino acid tryptophan. If you go and look at the chart and look up tryptophan and look and see what the code is, it is UGG, and tryptophan only appears once on the chart, so it's true. The mRNA codon UCU and AGU code for the same amino acid. If you go up and look at it, UCU and AGU, UCU is serine and AGU is serine. UCU and AGU, yes, they're both serine, so they code for the same thing. Okay? And let's see, 18. The mRNA codons GCU and GCC would share the same tRNA anticodon. That's false, because if this is my codon and this is my codon, the complementary anticodons are going to be different if it's different, right? GCU would be CGA, GCC would be CGG. So because they have, it could be the same amino acid, it's just not the same three-letter code. And then 20, stop codons can signal the end of the polypeptide. What are the 3 stop codons? So you've got to come up here and see where the stop is, and then look to your left, U, A, U, A, G, and here, U, G, A. So those are our 3 stop codons, and I just wrote them in there. And then it says AUG is a start codon, what's the amino acid for AUG. So we go up here and we look up AUG, methionine, and I abbreviate that as MET. Okay, so those are the answers to this worksheet, and you need to be able to, if I give you a DNA, tell me what is the messenger RNA, tell me what is the tRNA. If I give you tRNA, you should be able to figure out the complementary messenger and then the original DNA. So if I give you any of these, messenger, transfer, or DNA, you can find any of the other three. You just have to, sometimes you just have to get the complement. If you're going back to DNA, you gotta make sure you're replacing your U's with T's, or if you're going from DNA to RNA, you gotta make sure you're replacing your T's with U's. But if I give you one, you should be able to give me the other complementary strands. And then you should be able to use the chart. So make sure you can do all that. And if you have any questions, you guys can contact me. But these are the answers to your worksheet. Now we'll post this on the Google Classroom.